Welcome everyone to the BAA Wednesday webinar. This is the first one for a few weeks, and I'm pleased to report there's work being done in the background to bring more webinars and to convert some of the scheduled meetings for later this year into webinars. As always, this webinar is being recorded and will be available on YouTube. What you'll also start seeing is if there are a lot of people who join webinars, then you might find that sometimes we reach capacity and you'll be joined to YouTube, where you can also watch live, and we'll have this will be recorded and all our webinars are available on YouTube to watch. We'll again be doing Q&A after the presentation, and it's my great pleasure to welcome back Mike Fawkes, Director of the BAA Saturn, Uranus and Neptune section, to give us a talk tonight on Neptune at opposition. Over to you, Mike.
Right, thank you very much, Andy, and good evening, everyone, and welcome to this BAA webinar on Neptune. This shouldn't be a too long a webinar, maybe 20-25 minutes. And I'm also pleased to say that we're joined by Professor John Sussenbach, who is the Neptune coordinator of the section, who's also a very expert imager, particularly of Uranus and Neptune, and certainly will be on hand to answer any questions on imaging this planet. I think, probably like many of you, one of the things I do like about amateur astronomy is that there's often as not always something interesting going on in the sky. And we've just had a really excellent comet. And one thing that was happening, I didn't realise until it was pointed out on a BAA webinar in 15th of July, I think it was, the joint BAA-SPA webinar, when the SPA President, Robin Scatchell, pointed out that it would be possible in early August to see all the planets in one night's observation. It wouldn't be possible to see them simultaneously, but if you stayed up one night, you'd be able to see all of the planets. Fortunately for me, it was cloudy, but this gives a simulated view of what might have been seen on early August, that in the south you would have the moon there, Jupiter and Saturn. Later on in the evening, Mars would be rising and become very visible, plus Uranus. And if you stayed up towards the early hours, you'd see Venus rising, and in the twilight, the planet Mercury. Now, Mercury is quite a bright object, and depending on how deep it is in twilight, visible to the naked eye. And Uranus is potentially visible to the naked eye as well if we've got clear skies and no light pollution. And Venus, Mars, Jupiter and Saturn are easy naked eye objects. But all the planets visible, we notice that I've missed one out, and it's the planet Neptune. And the reason why I missed this out, it's the one planet that is definitely not visible to the naked eye. It's about magnitude 8. But it's still worth having a look. If nothing else, it represents the outermost planet of our solar system. But this status hasn't been, since its discovery, Neptune's position as the outermost planet has changed rather rapidly. Before I have a look at some observing things we can do to observe, I think we'll just run through the discovery of Neptune and how its status as the outermost planet has changed. And I'm sure it's a story familiar to everybody, but it's probably worth recanting. Now, the story really begins with this gentleman, Sir William Herschel, who discovered Uranus on the 13th of March in 1781. And once it became established it wasn't a comet but a planet, its orbit was determined, and then towards the end of that century, it became apparent that Uranus wasn't really playing ball with regard to its position. Its measured position and its predicted position started to differ. And it was ahead in the early part of the 19th century, but past about 1820, it started to fall behind. And nobody knew what the problem was. One idea was there was some errors in the mathematical computations which were found out. Some of the orbits that were used, data that was used to predict the orbit of Uranus were based on pre-discovery observations, which some people thought might be inaccurate. And when even allowing for the gravitational effects of Jupiter and Saturn, Uranus seemed to diverge from its predicted position. And various theories were expounded around at that time. Maybe Uranus had been hit by something, a comet was proposed. Some people even thought there was perhaps some resistive medium out in the depths of the solar system. And heaven forbid There was even ideas that Newton's law of gravity weren't universal and didn't work out deep in the solar system. Eventually, the idea that perhaps Uranus might be perturbed by another planet started to gain ground. And two people in particular started to investigate this problem. One was John Couch Adams in England, and the second one was Urbain Le Verrier in France. And these two people were very superb mathematicians, but definitely different in character. Couch Adams was an undergraduate and rather shy man. Urbain Le Verrier was probably totally different, and by all accounts wasn't a particularly pleasant person to know. These set off to try and establish if the disparity with Uranus's position was due to a planet beyond Uranus. It was probably after some computation, John Couch Adams came up with some results and contacted Professor James Challis at the Cambridge University Observatory for a letter of introduction to the Astronomer Royal George Airy. And he presented his positions, but not a lot seemed to have done about it. Le Verrier also worked on trying to establish if there was another planet out there and produced 3 landmark papers, one of which he sent to Airy. So Airy became aware that maybe this idea of another planet was correct. And it was only then that he actually got Challis to start to look for a new planet using the great 12-inch refractor at Cambridge University, the Northumberland refractor. But he hadn't told Le Verrier that Couch Adams had been working on this problem. Le Verrier encountered difficulties in France as well, trying to get people to look for this planet at its predicted position. But eventually, he contacted Johann Galle, who was an observer at the Berlin Observatory, who got permission from Johann Encke, the director, to use the 9-inch refractor there to try and see if he could find this new planet. And it was assisted by an assistant, Heinrich d'Arrest. And they actually started a search, and initially they tried to look to see if there was a star-like object that presented a disk with no success. But d'Arrest had found a new star chart of the area where Neptune was supposed to be, and very systematically they went through this area, ticking off the stars until Galle found a new star that was on this new chart. And this was effectively Neptune and was discovered on September the 23rd in 1846. On the next night with Encke, they confirmed the position and announced this to the world, which caused a bit of a furore in England because various people knew that Couch Adams had been working on this problem as well. And I think when this was released, quite rightly, the French thought a little bit upset because they hadn't realised that Couch Adams had been working on this problem. They thought that perhaps here in England we're trying to diffuse the great discovery by Le Verrier in predicting the planet, where the planet Neptune must be. Le Verrier, I think, at the background wanted to name the planet after himself, and I'm not too sure who eventually came up with the name Neptune, but Neptune was given to this planet, and this then became the outermost planet of our solar system. This lasted until the discovery of Pluto by this gentleman, Clyde Tombaugh. Born in a farming community in the USA, in Illinois, he built his own telescopes. Here's a picture of him with a 9-inch reflector. And he was observing the planets and sent his drawings to Vesto Slipher at the Flagstaff Observatory, the observatory which Percival Lowell built for the observations of Mars. And Slipher was quite impressed, so offered Tombaugh a job as an observing assistant to use a 13-inch refractor, a camera, if you will, to scan the sky to look for Lovell's mysterious planet X, to look for a new planet. And he used film, plates inside the film, and eventually, after doing a lot of searching and scanning plates scanning the plates together, eventually found an object on February the 18th in 1930, based on plates that had been taken in January. This object eventually became known as Pluto, and the Flagstaff Observatory held back until they'd observed it with larger telescopes and announced the discovery on March the 13th in 1930, which was a date which was, I think it's the 149th anniversary since Uranus had been discovered, and was also an anniversary of Percival Lowell's birthday. And immediately I thought this new Neptune planet was a major discovery. But as we well know, it was rather unusual. I initially thought it had a large mass, much greater than the Earth. But when the first satellite, Chiron, was discovered, the mass of Pluto gradually reduced down to a lot less than the Earth. And of course, Pluto has a rather unusual orbit. It swings outside, beyond Neptune and inside Neptune. And it's also inclined by about 17, 18 degrees to the ecliptic. And because of this, although this now was officially regarded as the outermost planet of the solar system, Pluto got closer to the Sun than Neptune from 1979 to 1999. So Neptune then became the outermost planet of the solar system. Once Neptune swung out again, Pluto swung out again, Pluto became the outermost planet until in August 2006, the International Astronomical Union decided to reclassify as a dwarf planet. Various other objects like this have been found in trans-Neptunian orbit, the Kuiper Belt objects such as Eris and such like. And so Pluto was reclassified. So from 2006 onward, Neptune is now the outermost planet of our solar system. So it's worth looking to try and find Neptune simply because of that. And it's fairly easy to find. But here I've got a few facts and figures about Neptune. It lies about 30 astronomical units away from the Sun, fairly low eccentric orbit. It's nearly 4 times the size of the Earth. It's the 3rd largest planet in our solar system in terms of mass. But because of this, and it's also completed 1 orbit around the Sun since its discovery, and that occurred in July 2011. But because of its great distance, even though it's a large object, it's rather faint. And we come into opposition on September 11th in a few weeks' time and lies in the constellation of Aquarius. And it'll be of magnitude 7.8. Relatively easy to find. We have Chi Aquarii, Phi Aquarii, and 96 Aquarii, a nice triangle. And this will be Neptune at opposition. And certainly it should be at magnitude 7.8, should be easily visible in a pair of 10 by 50 binoculars, especially if they're mounted on a tripod and you can get away from the dreaded light pollution. Heavily light polluted skies, well, you may need something rather larger. And certainly over the coming months, you'll be able to track Neptune's slow motion against the sky. This is a view to find Neptune from the software Stellarium. There's also an excellent chart to find Neptune in the BAA handbook. If you haven't got binoculars, then you can actually still take a picture of Neptune with a camera. I'm sure many people were photographing the recent comet, some with guided mounts and maybe sometimes having a camera on a tripod. And this shows a picture of the area around where Neptune is. Unfortunately, the sky doesn't have convenient arrows to point it out, but that is Neptune. And this was taken by just a couple of second exposure on a 50mm lens on a DSLR, where Neptune was rather low. So it's easy to do. When this was taken, Neptune wasn't visible from my garden and it was rather low. So I had to go out and seek somewhere where it was visible, which meant going down the road. And this picture was taken virtually underneath a street light, which shows you can overcome pollution. The exposure was short for a number of reasons. 1, to stop star trailing. 2, to reduce the light pollution. And 3, I was a little bit worried standing in the middle of a street with a camera pointing at some houses and was worried that people might get upset and maybe call the police. But I was hoping that it would be clear last night to do a complementary image of this to show Neptune's movement. Unfortunately, it was cloudy, but it's very easy to do. Not sure what this is. I don't know if it's a plane or one of Mr. Musk's satellites. But doing this is quite easy to do. Once you find Neptune, I suppose, as it's a planet, one of the nice things to do is to see if it's actually got a disk. And here is a picture of Jupiter I took quite a number of years ago now and shows one of its satellites, Io, in transit. And at the time, there's nearly 45 arc seconds across, and there's a little bit of detail visible in Io. And here is an image taken by John in 2014, virtually the same angular size that we'll have at this opposition, which is 2.4 arc seconds. So readily you can see that seeing Neptune's disk is a little bit of a challenge because it's rather small. It's not much bigger than Io. What telescope would need to detect a disk? Well, it's a little bit difficult to be pedantic. Looking at some of the observer's guides that you can buy, describe how to observe, some suggest that maybe if you find Neptune, you've got a telescope that's something of the order of 4 inches or 100 millimeters or larger with a high magnification. You might be able to tell that it's certainly non-star-like and may be able to resolve a disk. But given the size of this disk, detecting any features on this would seem to be pretty nigh on impossible if such features do exist. It's also interesting to note that 2.4 arc seconds across is comparable to a number of fairly well-known close double stars. So it gives you an idea how small this disk really is. For many of us, just seeing a disk is probably what we can do with amateur equipment, but Neptune does have a number of satellites. Last time I looked, I think there was 14, and the largest one is Triton, which was discovered by this amateur, although he was a very rich amateur, William Lassell, in 1846. Lassell had form in this direction and also discovered some other satellites using a large speculum mirror telescope. And he discovered Triton about 2 weeks after Neptune itself was discovered. And Triton is not particularly bright, it's less than the 13th magnitude. But visually, you may need a larger telescope. Depends on, again, on your light pollution and how high Neptune is in the sky. But some people have reported seeing it with telescopes of 200mm aperture. But certainly anything a lot bigger, and if you know where to look, should be suffice. And predictions of the position of where Triton is in relation to Neptune can be found on programs such as Stellarium or WinDuPos. But many people can image this as well. And John is an expert at doing imaging of satellites of Uranus and Neptune. And here is a recent image he took just literally a few weeks ago showing Triton and Neptune. Sometimes you can take a picture of Neptune and then process it in, say, Registax or Photoshop to bring out Triton. I've done this by taking videos of sort of quarter of a second, half a second exposure, overexposing Neptune, then bringing out Triton. And John took this with a fairly large Schmidt Cassegrain, 14-inch or 356mm across. And you would think if you've got slightly smaller telescopes, you'd be able to image Triton as well. We can actually image it with a very small telescope. And here is a picture taken by Graham Winstanley, an amateur in Lincoln Astronomical Society, using an ED 80mm refractor. He took a series of 10 by 60 second exposures using RGB filters. And this is an enlargement of the picture that he took, this refractor. That is Neptune, and hopefully on your screen you can see a rather small dot, and that is the 13th magnitude Triton. So it can be done with relatively small telescopes. Graham, in his notes, which were put on the BAA webpage, wistfully said that he knew that one of the other satellites of Neptune near it was predicted to be near here on this picture, but he'd probably need a larger telescope to do it. But one amateur in particular, it's very faint near it. It was discovered in 1949 by Gerard Kuiper, and it's sort of 18th, 19th magnitude. But here is a picture by Paul Leyland, certainly using a large amateur instrument, 400mm across. It's actually been able to picture both Triton and near it as well. Used 3-second exposure for getting Triton and Neptune, and a combination of exposures up to 400 seconds to get near it. And this is a 19th magnitude object. Paul has also been very successful at picking up some very faint satellites of Uranus. So it just shows you what you can do with the equipment. But for most of us, I think just seeing the disk may be what you can look out for. Now, although many professional astronomers looked at Neptune for many, many years. Nothing really was seen on the disk. And our first really view of Neptune as a planet came from Voyager 2 when it flew past the planet in 1989. And this is one of the most famous pictures of Neptune that Voyager 2 took. It shows a number of atmospheric features, sort of in blue haze, this large vortex, which was likened to Neptune's equivalent to the Great Red Spot and Neptune's Great Blue Spot. There's another one of these dark vortices here, and I think this is the one that got the nickname of Scooter, if I remember correctly, because it was moving relatively rapidly around the planet's atmosphere. This vortex seems to be where we're looking deeper into the atmosphere, and up here we've got high altitude clouds. And this seemed to have disappeared, but Hubble and various other Earth-based telescopes have been imaging Neptune for quite a while, and they've found that it actually has quite an active atmosphere. Vortices like the one we saw on Voyager occur from time to time, and this series of images by Hubble shows the appearance of the same vortex as it gradually disappeared, and there's another one up here as well. And I think with the two that were seen by Voyager, I think another 4 of these vortices has been seen by Hubble. And as you can see, some of the bright clouds span quite a substantial size across Neptune's diameter. Here is a picture taken by one of the Keck telescopes in methane light. Methane is prevalent in the atmosphere of Neptune. It's absorbent very much towards the red end of the spectrum. And this strips out a lot of the red-orange light going into Neptune. This is why we get this, what comes back, reflected back at us, is a sort of bluish colour. And also because of the high absorption of light by methane, anything that appears a lot bright in methane light images is relatively high in the atmosphere. And again, you can see some bright clouds that span a substantial portion of Neptune's diameter. And here we see one using the very large telescope at the European Southern Observatory showing various cloud features, and a relatively recent one taken by Hubble in September, though I'm not exactly sure of the date. So Neptune, even though it's right out in the depths of the solar system, does seem to have quite an active atmosphere. From an amateur point of view, perhaps just seeing the disk, as I said earlier, is probably the best that some people can do. And this is an early drawing of Neptune taken by BAA legend, Dr. W.E. Stevenson, and vaguely hints at some sort of vague banded structure, but not certain. A more recent drawing of Neptune is by very experienced visual observer David Gray using a very large Dalkirkham telescope over 400 millimeters. And here he's sort of vaguely showing some sort of white spot, which may be significant when we come back to looking at some images. But for many years, when amateurs started using imaging technology, the best they could do is just showing a disk. But certainly in this decade, certainly the last decade, cameras improved, amateurs have had access to larger telescopes. And many amateurs now are able to image not only the disk of Neptune, but also show bright cloud features on the disk as well. And here is a series of representative images over the last few years from 2015 until relatively recently, showing that sometimes the disk is rather bland, rather faint, and sometimes some brighter features can sometimes be seen. There's a brighter one here in 2016, which may have been something that David Gray reported visually. And it certainly does seem to show some bright clouds. Some of the best results, obviously in larger instruments, are by using red filters or near infrared filters, somewhere 6,000 nanometers or greater, and these seem to give very good results. But as you can imagine, imaging Neptune, given its small angular size, is not easy. It's certainly probably at the extreme of planetary imaging. Like all planetary imaging, you need a very good focus. And also, care has to be taken with the processing, no matter what processing system you use, because it's very easy to introduce artifacts into the processing of these images. So I think it's quite amazing, on a disk that's just over 2 arc seconds across, amateurs now can actually record features on Neptune. This is of interest to some professional astronomers because they don't always have access to telescopes that are looking at Neptune. So the discovery of these features is a good alert for them. And perhaps it's also trying to track how these features evolve is rather difficult, not only because I haven't got quite the resolution, but not many people are doing this. There's just a few amateurs will look at Neptune every so often. And it'd be great to get a greater temporal coverage of this, so we can actually tie some of these observations together to see if some of these features are in fact identical. So it is a bit of a challenge, and I said it's easy to introduce artifacts, and it's not always certain if what you've got is a real feature. But one trick that many people use is to take a number of images over a period of time, and it does depend upon the seeing. But certainly this is an image, a set of images taken by Australian amateur Anthony Wesley in 2014 over about an hour. So we can actually see this bright spot move with the rotation of the planet. And obviously if the seeing goes bad during this time, you may lose this feature, but it's a good confirmation that something is real and actually exists. So it's something that can be done. Now, over the next couple of months, the dominant planet in our night sky is going to be Mars, and quite rightly so. It's a good opposition for both hemispheres of the Earth, 22 arc seconds across, so even relatively small telescopes will be able to see some detail on Mars. But it is flanked by our two ice giant planets in our solar system. Uranus is towards the east, just below Aries, and Neptune to the west below the Square Pegasus in Aquarius. And Mars will obviously be a focus of attention, but certainly it would be a nice diversion if you've never seen it before to have a look at Neptune and just find it, and perhaps even see a disk and maybe pick up Triton as well. And maybe if you've got a telescope that's suitable for imaging, even down to 200 millimeters, it's worth having a go and seeing if you can get a disk, and may even be able to pick up one or two of these spots. We can't guarantee this, but Neptune does seem to regularly show bright features that can be seen with larger amateur instruments. So it's our outermost planet. How long this will reign, there's always ideas that there may be further planets deep in the solar system, I don't know. But I think for the moment, Neptune represents the outermost planet of our solar system, and well worth a look. With that, Andrew, I'd like to finish. I'd like to thank everybody for listening. I said this would be a relatively short one. And if there are any questions, perhaps bring John online as well, and we'll do our very best to answer them.
Thank you very much, Mike. That was a fascinating webinar. I'm pleased to say we've got about 85 people with us tonight across Zoom and YouTube.
Yeah.
And just before we get on to the Q&A, I'm just going to give a little bit of a plug for our next webinar, which is Saturday, the 5th of September, and it's the BAA Autumn webinar, replacing our autumn meeting. At 11 o'clock, we have Professor Christine Dunn on the life and death of black holes. And then at 2:30, it's Dr. Andrea Font, Stumbling in the Dark, the search for the universe's missing mass. For the Q&A, if you have any questions, we're going to do it the same as we've done previous webinars. You'll see there's a little Q&A button in the bottom, which you can click, and then you can type questions in, and we can read them out. And I'll try to keep an eye on YouTube. And I think, Mike, shall I promote John Sussenbach?
Yes, please do. If we could welcome John as well.
John, I'm just doing this now, and it'll probably take a few seconds to work itself through the system. Hopefully that's now promoted John. I can see him there as a panelist. And John, you're still on mute, just in case you're talking.
You're there now, John.
If not, what we'll do is, looks like looking good.
No image yet. Anyway.
I guess even if we can't see you, if there's anything you want to share,
expect you'll be able to. There's a little sort of share screen button.
Well, I just want to underline, thank you, Mike, for your great presentation, because although it is small, it is a fascinating planet. And of course, it's smaller than Uranus, but it's more active in its atmosphere. And that is actually what intrigued me. That was in 2014, when Ricardo Hueso, a professional astronomer in Spain, Bilbao, invited the amateur world to see whether they could image and capture a big, bright storm on Neptune. And that was for the first time, as a matter of fact, that we really tried it because you need some courage to start. And many of us were able with a C11, 11-inch telescope or bigger to image that spot. And the interesting thing is it was not just only imaging, it was also possible to measure the position of that spot daily. Now the wind speeds on Neptune are very high. Around the equator, it is around 400, we speak in kilometers per hour. And it means that in one day, the drift was about 20 degrees. And it is possible to determine the precise position of these bright spots using wind UPOS. Now the problem, of course, is how is the orientation of this globe? Is it small? And when you are going to process that tiny disk, very easily you enhance contrast and lose a bit of the disk. So that makes it, of course, very difficult to do precise measurements. But the lucky thing is that almost in every image of Neptune that you make, Triton is there. And just by enhancing contrast and the brightness, you will always see it. Then, of course, Neptune is overexposed, but you can very accurately pinpoint the position of Triton. And then you can go with your image with Neptune in the normal exposure time and this the position of Triton derived from the overexposed image. You can go to WinUPOS and position your image precisely on the prediction of WinUPOS. And then you can very accurately even determine the position of these spots. And then it turned out that many amateurs were able to contribute. And you know, of course, there were the measurements of the Keck and the Hubble telescope. And then, funnily enough, you found points determined by amateurs with a C11 or a C14, and it fitted quite well. This was, in my opinion, one of the nicest examples of a pro-am contribution. And this was also acknowledged in the author of the papers that came out. So Neptune is an interesting planet, and it's important for professionals. And we as amateurs can really contribute and have our share in exploring that planet. Imaging is not easy. When I do it in the prime focus of my C14, and then I get a frame rate of about 10 frames per second. That is rather low. And so you need good seeing, otherwise your image will be blurred. But if you do it that way, using this infrared filters, it is really possible to detect these spots. And if there is no spot, what you can see is a darkening of the northern hemisphere. It's always a little bit darker than the southern hemisphere. So it's worthwhile, and certainly for us here in the northern latitudes, Jupiter and Saturn are so very low and difficult to image. And Neptune is doing better now at around 30 degrees of the horizon, which is quite nice.
And I see we have...
Might be good. We've got some questions come up, Andrew, but perhaps while we're doing the questions, maybe John, you said you'd taken an image last night. It'd be good to show literally hot off the press image by sharing the screen. We've got the first question, which is from Jack. Good evening, Jack. It said the different features seen in amateur pics are due to orbital rotation, ? I think it's a mixture of different features appear at different times. They come and go. We don't know the exact frequency. And also, as I showed earlier, that some of these features do move with the rotation of the planet, and as John had said, so sometimes there are new features coming in. It's not orbital rotation that's going around the sun, but we see features on different sides of the planet due to the rotation of the planet, and they do come and go. The second question that's popped up from Gary Hunt. Evening, Gary. Have you any comments to make about Neptune's rings? What are the possibilities for amateurs to image them? That's a very intriguing question about Neptune's rings. They're very faint. There's three main rings, the Verrier ring, the Couch-Adams ring, and the Gall ring. And they are rather faint. And to the best of my knowledge, nobody is actually in the amateur world has imaged them. If we go back to Uranus, actually, though, there has been efforts to image the rings of Uranus. And one person who has been doing this is Martin Lewis. And I don't know if Martin is online. If he is, we'll get him to make a comment on that a little bit later on. But Martin has been using his large Newtonian reflector to image Uranus to try and capture these faint rings. And his results are fairly tantalizingly close. I mean, it has been seen, the Uranus rings have been seen by, potentially seen by other amateurs as well, although some of the images are really noisy. Perhaps the most convincing image I've seen of the rings direction, so it's the Epsilon ring, the brightest one, was actually taken at the Pic du Midi by some amateurs, including French amateur Marc Delcroix. And that does show that very well. But there has been tries to Uranus, but I think Neptune's rings are a lot fainter, but who knows? But to the best of my knowledge, nobody's been done that so far, but it might be worth having a go.
I'm not sure if Martin Lewis is on or not. I can see we have a Martin on Zoom.
Yeah. Well, if it's Martin, if you could do by chat, and then we could bring Martin on that, right?
Yeah, that's
go
what
on the next question.
So yeah, just type
There's another question from Eddie Carpenter. Hi, Eddie. You've got a question which is about Phoebe. Is it a moon or comet or what? Well, Phoebe is actually a satellite, not of Neptune or Uranus. It's actually of Saturn, and it's its outermost satellite. If you'd just like to resubmit your question, Eddie, if you are listening, because we are talking about Neptune, and Phoebe is a satellite of Saturn. It may well be a captured asteroid. I don't know. The next question has popped up from Diane. Hi, Diane. Does Neptune have a constant rate of rotation? That's a really interesting question, and it cuts across what John talked about earlier on, is that we believe that Neptune, perhaps deep in its atmosphere, may have a rotation period. It's often quoted of just over 16 hours. However, the other upper atmosphere has got winds in it, and these rotate, not dissimilar to what we see on Jupiter, Saturn, and Uranus, but for Neptune, the equatorial winds are moving slower than the planet, and the winds at much higher latitudes are moving a bit faster than this average rate of the planet. But it perhaps deep down it has a constant rotation, but for the features that we see that are atmospheric, they do show drifts depending upon latitude. Have you got your image, John?
I was going to say, we do also have a question on YouTube.
Okay, let's go.
I think it's probably been answered by John, but I'll read it out anyway.
Okay, yeah.
Which is this is from Zad, and is there any potential for IR imaging of Neptune by amateurs?
Yes, and I'll let John reinforce that again. Way to you, John.
Yes, absolutely. So infrared and red infrared is very fine to detect the spots. You can see them in a color image, but the easiest is to do it with an IR filter.
There are quite a few IR filters on the market as well. You can get some that are sort of up to 685 nanometers, 742 nanometers. So any of these filters should be more than adequate, and they're reasonably affordable like other filters. So yeah, it can be done.
As for the filters, Mike, because Neptune is so faint, you don't want to use a very narrow band filter, because you lose then too much light.
Yeah.
So everything above 600 nanometers is already usable, and it's good. You go to 750, and many of the current cameras are quite sensitive in the infrared, even till 1000 nanometers. Then still 30% of the light is captured. So they are quite sensitive, but nevertheless, the planet is faint, and it's not easy to get a higher rate than 10 or 15 maybe.
Any more questions on YouTube, Andrew?
Just having a look. There's nothing else coming through.
Okay.
And no more questions here. Again, if anyone does want a question, ask a question, just use the Q&A button.
Yeah. I just wondered if we just got time, if John can flash up his image taken from last night.
That would be fascinating to see.
That's not that easy, I'm afraid.
Okay.
I'm still processing, as a matter. But that's right what you mentioned. You should be very careful with processing, because very easily you are processing grains, and you get artifacts. So you really need confirmation in general by seeing the rotation of the spot, seeing it back the next day on the predicted value, etc. So we can be careful with that. But in the infrared, it is possible to see the spot already during capturing, if the spot is big enough and bright enough.
If John can get his image up, that would be great.
And I see we've actually got some more questions coming in. I'll just click off the ones which are done.
Okay. And there's another one from Gary that says, I understand that some winds on Neptune have been estimated as being supersonic. Is it now understood how this works? I would very much like to answer your question, Gary, but not being an atmospheric physicist, I'm afraid I will fall down really badly. So the simple answer is I don't know what the mechanism would be, but I'm sure that somewhere some atmospheric physicists are addressing this problem. But beyond that, I'm sorry to say, I don't know. And then we have another question from Eddie Carpenter. He says, I believe Proteus is bigger than Nereid. Has any amateur photographed it yet? Yes, you're correct, Eddie. Proteus is a little bit bigger than Nereid. I can't remember the exact numbers, but it's only a few tens of kilometers bigger. To the best of my knowledge, nobody has photographed it yet, but who knows? I mean, having seen some of the images we showed earlier on of, picking up Nereid, and of course picking up some of the very faint satellites of Uranus, maybe somebody would like to have a go sometime. So we've done that one. Any luck, John?
Well, I'm looking how to make it visible to you.
There should be a button on the bottom that says share screen.
It's the green button. If you move your mouse around on the Zoom window, you'll see a green button in the middle.
Is it like this? Let me see.
Any luck seeing that share button?
Yes, I've seen that, but I'm still working on it. Yes. Well, you see, at the age of 81, I'm not that clever. Working with it.
What should happen is when you press the share screen button, it'll
Yeah.
come up with a window which has your desktop, so you could share the whole desktop, and it also has other options like just sharing a specific application.
I see that. I see that desktop. It has an exclamation mark.
And the one thing to note is if you've got anything which might be in any way personal or sensitive, like emails, you may not want to share your whole desktop. You might want to just share an image, which would be kind of one of the other sort of little boxes you see within there.
Ah, the wonders of technology. Doesn't seem to be working, does it?
No, if not, I don't know how quick it would be to send it to Mike, and then Mike could share it.
Yeah. Okay, let me see.
If not, you'll have to just go on the BAA observers page, ASA.
Yeah, well, it will encourage people to have a look on the BAA website.
Yeah, it should.
So I expect most people know, but if you go onto
Yeah.
the website and if you go to the community area, there's a place where you can see all the recently uploaded images.
Yeah. So that might be the best way of doing it now. If we run
Actually, why don't I quickly share my screen? I'll just show what I mean, which is, go there, share. So I'm sure this is kind of old hat to many people, but to anyone who hasn't seen it, this is the BAA homepage. If you go to community and then recent images, and you'll see recent images uploaded by members. In the kind of the most recently uploaded one will be in the top left. And you can see a few nice ones of Mars on there. And actually, just whilst I'm here, again, probably everyone on the call on this Zoom knows it, but we'll be adding any new webinars onto the events, which you can get to from there, or you can see recent events just down here in the bottom left of the screen. So we can see tonight's Neptune at opposition, then we've got the autumn webinar and the AGM, but we will be adding a few other events between the autumn webinar and the AGM. So if you keep watching the website, you'll see more Wednesday webinars coming up.
We've just got another question popped up, Andrew, which I'll try to answer. It's from Jeremy Shears. Hi, Jeremy. He asked the question, any scope for amateur spectroscopy of Neptune? To the best of my knowledge, I don't think anybody's tried, but I know a few people have tried spectroscopy of Uranus. So if anybody's willing to have a go, it'd be interesting to see what results they get. I imagine larger instruments may be required, but like I say, it'd be an interesting project to try out.
It's probably not too difficult, because if you do it at low resolution,
yeah,
then and you see the whole spectrum, because Neptune, it's not one of the very, I think once you get sort of 9th, 10th, 11th, it gets very difficult. But
I mean, it's magnitude 8, and there's a lot of methane absorption in the spectrum, but I don't know of anybody who's done it. But it'd be interesting to see if somebody would have a go, and I'd be very pleased to hear from anybody if they do.
And that prompts me, just whilst we're on, to have a quick look at the BA spectroscopy database to see if we have anything for
I don't know.
Neptune in there.
Well, Christopher Pellier has done some spectroscopy of Neptune and Uranus.
Okay, thanks.
Yeah. There's some quite spectra, nice spectra, as a matter of fact. Yeah.
I see we have spectra of Jean Guaro flow. So I'll just see what the plot comes out like. If I just, I'm now going to share a different screen just for a moment. We go here. There you go. This is the BAA spectroscopy database.
Oh, excellent, excellent.
And there you can see a whole load of different spectra which are on there. Show a nice. I'm afraid I'm not sufficiently familiar with planetary spectra to point out the features in there, but there's certainly a wealth of information.
You're used to things that are a little bit warmer, aren't you?
Yes. Yeah, sort of a few thousand Kelvin is
2000 K
I
watt,
usually
yeah.
in stellar spectroscopy.
Yeah.
And for anyone who, there's a link to the spectroscopy database on the BA homepage, and then you go to review spectra and you can look at things. So for example, here I've gone planet, filter object list, and then there's Neptune. And that gives the spectra, and then you can plot them individually or plot 20, up to 20 in one go.
Yeah. There's just a question just coming from Dave Boyd. Hi, Dave. I know he's done something on Uranus, and he just says that he could do a plot of Neptune if necessary. So Dave has actually done one, which is quite good. So,
well, do you want to share?
Don't know if you're there, David, if you want to do it.
Let me just, I've found David. David, I'm just going to promote you to panelist. So I find it usually takes a few seconds for it to work its way through the system. And then you should have the ability to share, should you? So I think David's been promoted. It's probably just sorting itself out in his computer.
Yeah.
And unless he doesn't want to speak.
Okay, okay.
But I think he's still on mute at the moment. We'll give him a few seconds to see if it sorts itself out. No, I don't think it's looking like there's going to be anything.
Okay, I think John's.
Oh, hello, David.
Hello, David.
I wasn't getting the microphone thing up, so I couldn't unmute myself.
Yeah, I think once we promote you, it probably does a few things which maybe take 10, 20, 30 seconds to sort themselves out.
Okay, I'm going to share the screen.
Excellent.
Does that work from your end?
Yep.
Yeah.
That's a spectrum of Neptune I took several years ago now, but it's basically a solar spectrum, but with these huge dips, which I think are methane absorption bands.
Yeah.
So it's not terribly exciting, but if you were trying to find out what was in the atmosphere of that planet, the spectrum will tell you.
Yeah.
That's a spectrum of Neptune I took several years ago now, but it's basically a solar spectrum, but with these huge dips, which I think are methane.
I think someone's probably got the their sound on or something else, so it's repeating itself.
Trying to find out what was in the atmosphere of that planet.
What I'm going to do is I'm just going to and then mute people in turn. So I'm now going to unmute Mike and unmute David. There we go. You should be back.
Right. Sorry about that. I don't know if I was doing anything wrong or.
No, I've got a feeling it might have been coming from John, so I was kind of going through muting in turn, but
yeah.
So
just switch the camera on and say hello. Hi. Anyway, that was just to show you what I got a few years back.
And I would guess the interesting challenge would be is if there are any spots to see if you can notice any difference in the spectrum.
Yes.
That would be a challenge, but would be an interesting.
Yes. What you want to take is a time series of spectra, maybe a few weeks apart, and see if it changes.
Yeah, yeah. Excellent. Don't know if John's had any more success with his image.
Yeah.
Well, I think I don't know if there's any more questions popped up, but I think I've answered most of them now.
Yeah, there's no more questions on YouTube. I'll just try unmuting John again, but I think he was having problems sharing the screen, so I'm not
sure. Everybody have to look tomorrow on the BAA webpage.
So I'll say bye anyway, thanks.
Okay, cheers, David. Thanks for that. Much appreciate it. A bit of an interactive session, this one.
Yes.
Makes them more fun.
It does indeed. You learn something new every day. That's another advantage of amateur astronomy. There's always something new to pick up on.
Right, well, thank you very much again, Mike, for a fascinating talk tonight.
Okay.
And also to John and David for joining in at short notice. And look forward to seeing the observations of Neptune coming in.
Okay, thanks, John.
Yeah, bye-bye. Bye-bye.
Hope to see many
Bye,
of you
everyone.
on the Saturday BAA webinar. So that's on the, I think it was the 5th. Let me bring up my notes. Yes, Saturday the 5th of September for the autumn webinar.
Okay.
Thanks
great.
very much.
Cheers. Good night, everyone.
Bye.